Hello students, I'm the A-level guy and today we're going to be studying about modeling with quadratics. So, grab a notebook, grab a pen, and let's begin. So, as you know, the general form of any quadratic equation is ax squared plus bx plus c. C is the y-intercept, right? So, what do we do when we model with a quadratic? So mathematical modeling is just about changing the variables into some quantity. For example, I'm going to change this to height and I'm going to change this to time. So now if I look at the graph, which should look something like this, the normal graph for quadratic equation, so the y-axis will represent height and the x-axis would represent time. Now if I change this from height to, let's say, speed or velocity, then the y-axis will change to speed or velocity. This way the graph remains the same, or maybe it changes, but all we're doing is changing the variables and plotting the graph. So when we had a normal equation in terms of x, then if we input some value of x, we'll get some value of y, right? Let's say I put in x equals 2, I'll get some value of y. I put x equals 3, I'll get some value of y. The same way, when we model with a quadratic, we're going to put in the variable that we choose here, for example, time, like we had before. So if I put in time, I'm going to get the height at that point of time. When I put in, let's say, another value of time, I'm going to get another value of height at that time. So, using this, we can create models of real-life situations and therefore predict the outcomes of many real-world examples. For example, I am throwing a ball from the ground at some degrees from the horizontal, right? So it's going to follow a path that looks something like this. It looks like an upside down quadratic. So all I'm going to do is find the model of this path. I'm going to draw a graph. I'm going to find the equation of the function, and there you have it, a mathematical model. Now in this mathematical model, I'm going to use horizontal displacement and height. So instead of x, I'm going to have s, and instead of f of x, I'm going to have h. So my y-axis would be height, this would be displacement in the horizontal, and therefore now all I have to do is put in some value of s, let's say 2 meters, and I'm going to get the height from the quadratic equation. Now here, you notice that I've drawn the graph a little bit on the negative. I should have drawn this like this, because displacement starts from 0 and height starts from 0. So the equation should look something like this, and then at 2 we can find the height. And the same thing we can do for height. If we know the height, we can find the displacement as well. So let's say I have some height which is over here. I'm going to find the displacement when the height is this. Now notice, because this is a quadratic equation, we're going to get two values of height. So we're going to get two values of height, and you may be asking the question to calculate these two, or use the bigger one or use the smaller one, but you know why there are two values, right? So now we're going to move on to a challenge question on mathematical modeling in the Pure Year 1 book. So the question says that a team of engineers are studying the stopping distance of a particular car. So they've drawn a mathematical model that this is the distance that it stops, and it's in the form of a quadratic, right? So they say that the stopping distance is 6 feet when the speed, which is x, is 20 miles per hour, right? And it's 14 when it's 30 miles per hour. And then it is 24 when it is 40 miles per hour. So we have to find the equation of the model that they're using. So we know that the stopping distance is 6 and the input is 20. So instead of x, I'm going to write 20. So for our first equation, we're going to get 6 equals a, which is some constant, which we're going to find out, plus 20b plus c. Second equation, 14 equals a times 30 squared plus 30b plus c, and 24 equals a 40 squared plus 40b plus c. Now you have 3 equations, you have 3 missing values. So you can solve these equations. What I'm going to do is I'm going to subtract the second equation from the first and the third equation from the second. So when I subtract 2 and 1 on our 2 minus 1, we're going to have 14 minus 6, which is 8, equals c and c are going to cancel out. 900 minus 400, 500a plus 10b. And subtracting third from the second, 1600 minus 900, which is 700a plus 10b equals 10. Now you have 2 simultaneous equations. Solve for a, solve for b. So solving this, we get 10b equals 8 minus 500a. 10b equals 10 minus 700a. Equate these. 8 minus 500a equals 10 minus 700a. This becomes 2. This comes here. This becomes 200. And a is 0.01. So we got the value of a. Well, I'm going to write that here. Okay. Now we have to calculate the value of b. We can calculate the value of b from this equation. So 8 minus 500 times 1 over 100 equals 10b. 100, 100. So 3 equals 10b. b equals 0.3. So you get b equals 0.3. And now you can put these values into any of these equations and get the value for c. Okay, now that we know the values of a and b, we can put them into equation. 6 equals 20 squared times a, which was 0.01, plus 0.3 times 20 plus c. We put them in the first equation and we're going to solve for the value of c. This is 400 times 0.01, this is 4. 0.3 times 20 is 6. 6 and 6 cancel out. Negative 4 equals c. So our value of c is negative 4. Once we know that, we can complete our equation. So the stopping distance equals 0.01 x squared plus 0.3 x minus 4, where x is the speed of our car. Now in the second part of the question, they ask us to calculate the speed of our car based on the skid mark. So the stopping distance is assumed to be 20 feet. So we're going to put that equals to 0.01 x squared plus 0.3x minus 4. Now you can put this quadratic equation into your calculator and you're going to get two values. One is going to be negative, one is going to be positive. Now you have to use your brain and think that the car cannot have a negative speed because it would be traveling backwards then. And I don't think that a car traveling backwards on a highway is a very ideal situation. So we're going to cancel the negative part and we're going to keep the positive value, and you should get an answer of around 36.1 miles per hour. That is the challenge question solved. Thank you for watching, and comment any doubts in the comment section down below. Yeah.